Good morning, my dear students of first secondary. I am Mr. George, and today we are going to study our first lesson in geometry. This lesson is called Similarity of Two Polygons. So let's go. Geometry, first secondary, unit 1, lesson 1, similarity of two polygons or similarity of polygons, prepared by Mr. George Milad. Similarity of polygons. Definitions. Two polygons M1 and M2 of the same number of sides are said to be similar if the following two conditions satisfied together. Here we say that two polygons M1 and M2 are said to be similar if the following two conditions satisfied together. Their corresponding angles are congruent, the lengths of their corresponding sides are proportional. The lengths of their corresponding sides are proportional. In this case, we shall write the polygon M1 similar. This is the symbol of similarity. The polygon M1 similar to the polygon M2. That means the polygon M1 is similar to polygon M2. Okay? In the opposite figure, here are two polygons. The first polygon is ABCD and the second polygon is XYZL. If measure of angle A equals measure of angle X and measure of angle C equals measure of angle Z and the measure of angle B equals measure of angle Y, measure of angle D equals measure of angle L, and the corresponding sides are proportional, then we say that the two polygons are similar. Measure of angle B equals measure of angle Y, measure of angle C equals measure of angle Z, okay? And the last one, measure of angle D equals measure of angle L. Each angle is equal to the measure of the corresponding angle. Here, angle L corresponds angle D, and measure of angle X equals measure of angle A, measure of angle Y equals measure of angle B. There are the corresponding angles. هما دول ال corresponding angles. ماشي؟ And the sides are proportional. The sides are proportional, which means if AB over XY, AB over XY equals BC over YZ equals CD over ZL equals DA over LX. So if we divide AB over YX, the ratio will be equals to BC divided by ZY equals the ratio between CD and ZL and the ratio between DA and LX. Okay? Then the two polygons ABCD similar to the polygon XYZL. Okay? Example. Or very important remark first. Let K be the similarity ratio of polygon M1 to polygon M2. So if we divide AB over XY, two corresponding sides in two polygons, and the result will be K. If K bigger than 1, then the polygon M1 is an enlargement of polygon M2. When K is called the ratio of enlargement or enlargement ratio. If we divide two corresponding sides of the polygons and we find that K bigger than 1 and smaller K bigger than 0 and smaller than 1, then the polygon M2 where K is called shrinking ratio. So if we divide two corresponding sides in the two polygons and the ratio bigger than 1, then we say that the polygon M1 is an enlargement of polygon M2. And if we divide two corresponding sides and you find that the ratio bigger than 1 and bigger than 0 and smaller than 1, then the polygon M2, the two polygons, the polygon M2 is shrinking of the polygon M1. And if the last one k equals 1, then the polygon M1 is congruent to polygon M2. In general, you can use the similarity ratio calculation of the dimensions of similar figures. We use the similarity ratio to find the lengths of the other sides of any polygon. Okay? If each of two polygons is similar to third polygon, then they are similar. Here, if polygon 1 similar to polygon 2 and polygon 3, here polygon 1 similar to polygon M2 and polygon M3, then M3 and M2, the two polygons are similar. Okay? And this is very important remark. Remark 3. All regular polygons of the same number of sides are similar. What do we mean by regular polygons? Regular polygons means all the sides are equal in length and all the angles are equal in measure. The square is a regular polygon. Okay, regular quadrilateral polygon. The equilateral triangle is a regular polygon, regular three sides polygon. Okay, the equilateral triangle. So all the equilateral triangles are similar and all the squares are similar. Okay? Okay. Example 1. In the opposite figure, if the two polygons A, B, C, D and X, Y, Z, L are similar, find the scale factor of similarity of two polygons A, B, C, D to polygon X, Y, Z, L. Okay, let's solve it together. Here the two polygons are similar. Since the two polygons are similar, then measure of angle A, the corresponding angles are equal in measure. Measure of angle A equals measure of angle X. Okay? Measure of angle B will be equals measure of angle Y. Again, since the two polygons are similar, then measure of angle A equals measure of angle X. So we can write here measure of angle X will be equals to 70 degree. And measure of angle B will be equals to measure of angle Y. Measure of angle B equals measure of angle Y. So we can say that measure of angle B equals 65 degree. Very good. Measure of angle C equals measure of angle Z. Measure of angle C equals measure of angle Z. So we can say that measure of angle Z will be equals to 135 degree. Okay? Okay. What about angle D and angle L? We all know that A, B, C, D is a quadrilateral. Therefore, measure of angle D will be equals to 360 minus 70 minus 65 plus 135. So we can find measure of angle D, which is equals to 90. And we can find also measure of angle Z, which is equals to the same angle, which is equals to 90. Okay? Okay. But here also we need to find the scale factor of similarity. The scale factor of similarity, how can we find the scale factor of similarity? First, we are going to write AB over XY equals BC over YZ. The first two letters over the first two letters. AB over XY, BC over YZ equals CD over ZL, the two corresponding sides, equals AD okay, AD over XL. Okay, now you can write the corresponding ratio. AB equals, where is AB? AB equals, we don't know the length of AB, so we will write AB over XY. XY equals 3 centimeter equals BC equals 2.1 over YZ. Where is YZ? YZ equals 1.4 equals CD, we don't know its length, so we write CD over ZL. ZL is 1.8 equals, the last one will be AD 3 centimeter over XL. We don't know its length. Okay, here you can find that there is a complete ratio here, which is 2.1 over 1.4. If we put it in the simplest form, 2.1 over 1.4, okay, divided 7 will be equals to 3, divided 7 will be equals to. So this ratio, 2.1 over 1.4, will be equals to 3 over 2. 3 over 2 is called the scale factor of similarity. So this is the scale factor of similarity of polygon ABCD to polygon XYZL. This is the scale factor of similarity. Okay? Okay. Let's solve it again by using the PowerPoint. Here he wants the lengths of the unknown sides and the measure of the unknown angle in each of the two polygons. Okay? Since polygon ABCD similar to polygon XYZL, measure of angle A equals measure of angle X equals 70, measure of angle B equals measure of angle Y 65, measure of angle C equals measure of angle Z equals 135, okay, and the measure of angle D equals measure of angle L. Here you have to write the two polygons in the same order. So measure of angle A, the corresponding letter will be X. Measure of angle A equals measure of angle X. Measure of angle B equals measure of angle Y. Measure of angle C equals measure of angle Z. And the last one, D, equals measure of angle L. So to find the measure of angle D, which is equals to measure of angle L equals 360 minus 70 plus 65 plus 135, which is equals to 90. Second, since polygon ABCD is similar to the polygon XYZL, so AB over XY will be equals BC over YZ equals CD over ZL equals AD over XL. We write the lengths of each side. AB over 3 equals BC. This is 2.1, not 210. This is 2.1 over 1.4. 2.1 over 1.4. This is equal to CD over 1.8 equals 3 over XL. Okay? If we simplify the ratio 2.1 over 1.4, we get the ratio 3 over 2. Okay? How we will find the length of each side? By cross multiplication. So to find the length of AB will be equals to 3 multiplied by 3 over 2. Find the length of AB again will be equals to 3 multiplied by 3 over 2. 3 multiplied by 3, the scale factor of similarity, over 2. Okay, to find the CD will be equals to 1.8 times 3 over 2. And what about XL? XL will be 3 multiplied by 2 over 3. So again AB will be equals 3 multiplied by 3 over 2, which is equals to 4.5. Which is equals to 4.5. CD will be equals to 3 multiplied by 1.5. 3 multiplied by 1.5 over 2. It will be equals to 2.7. 7. Okay, and the last one XL will be 3 multiply 2 over 3, which is equals to 2 centimeter. Okay, okay. Another example, very important remark. The ratio between the perimeter of two similar polygons equal the ratio between the lengths of two corresponding sides of them. So here the ratio between the perimeters of two similar polygons equals the ratio between the lengths of two corresponding sides of them. So to find the ratio between the perimeters of two similar polygons, it is the same as the ratio between any two corresponding sides of two similar polygons. Okay, example. Here two similar polygons, the lengths of one sides of them are 3 centimeter, 5 centimeter, 6 centimeter, 8 centimeter, and 10 centimeter. And the perimeter of the other polygon equals 48. Find the lengths of the sides of the second polygon. Here we know all the lengths of the sides of the first polygon, and we know the perimeter of the second polygon. And he asks me to find the lengths of the sides of the second polygon. Okay, solution. Since the two polygons are similar, therefore perimeter of first polygon over perimeter of second polygon equals the ratio between any two corresponding sides. Okay. So here we know that the side of the first polygon is 3 centimeter, but we don't know the length of the first side of the second polygon. And 5 over side 2, 6 equals 6 over side 3 equals 8 over side 4 equals 10 over the side 5 or the fifth side. All of this equals to perimeter of triangle 1 or perimeter of polygon 1 over perimeter of polygon 2. Mister, we don't have the perimeter of polygon 1, but we can find it. The perimeter of polygon 1 equals 3 will be equals to 3 plus 5, 3 plus 5 plus 6 plus 8 plus 10. So the perimeter of any polygon is the sum of its side lengths. Okay? So the perimeter will be 3 plus 5, 8, 8 plus 6, 14, 14 plus 8 equals 22, 22 plus 10 equals 32. And he gives us the perimeter of the second polygon, which is equals to 48. Here you have to put the scale factor of similarity, 32 over 48, in the simplest form, which is equals to 2 over 3. Okay? So to find side 1, very easy. Side 1 will be equals to 3 multiplied by 3 over 2. And side 2 will be 5 multiplied by 3 over 2. Side 3 will be 6 multiplied 3 over 2. Side 4 will be equals 8 multiplied by 3 over 2. And the last side, side 5, will be equals 10 times 3 over 2. Okay? So, side 1 will be equals 4.5 by using calculator. Side 2 will be equals 7.5. Side 3 equals 9. And side 4 will be equals to 12. And the last one will be 10 times 3 equals 30. 30 divided by 2, which is equals to 15. Okay? If you add the side lengths of the second polygon, sure that their perimeter will be equals to 48. Another example. In the opposite figure, polygon ABCD similar to polygon EFGH. Okay? Find the scale factor of similarity of polygon ABCD to polygon EFGH. Find the values of X and Y. Okay? Here is the problem in the opposite figure. Here we have that polygon ABCD is similar to polygon EFGH. Okay? find the scale factor of similarity of polygon ABCD to polygon EFGH. Okay, find the values of x and y. First, we are going to solve it together. Here, since ABCD similar to EFGH, therefore the corresponding sides are proportional. So we will write AB over EF equals BC over FG equals to CD over GH equals AD over EH. Okay, AB over EF equals BC over FG equals CD over GH, and the last one will be AD over EH. Okay, let's write the length of each side. AB equals y plus 2 over EF 6 centimeter equals BC we don't know BC, the length of BC. FG also we don't know the length of FG. This is equals to CD equals 15 over GH x centimeter equals AD 12 over EH, which is 8 centimeter. Here we have a complete ratio, which is 12 over 8. Put it in the simplest form. Divided 4 will be equals to 3. Divided 4 will be equals to. So the scale factor of similarity is 3 over 2. So now we can find the value of y and x. How we are going to find the value of y and x? Here 15 over x equals 3 over 2. Cross multiplication. So you can find that 3x will be equals to 30 divided by 3. So x will be equals 10 centimeter. Okay, and also y plus 2 cross multiplication. Y plus 2 will be equals to 6 times 3 over 2. 6 times 3 equals 18. 18 over 2 equals 9. Okay, 2 will go to the other side. 2 will go to the other side. So y equals 9 minus 2, which is equals to 7 centimeters. So here you find the scale factor of similarity, and also you find the value of x and y. Okay. Again, solution. Polygon similar to polygon. You will write the corresponding sides is equals to similarity ratio. Okay. The similarity ratio here will be equals to 3 over 2 by cross multiplication. First, the scale factor equals 3 over 2. Okay. And 15 over x will be equals to 3 over 2. Cross multiplication, x will be equals 10 centimeter. And here y plus 2 will be equals 3 over 2. Y over 2, y plus 2 equals 9. So y equals 7 centimeter. Okay, let's go to another example. Complete the following. If each one of the two polygons is similar to a third polygon, if each one of two polygons is similar to a third polygon, here he means that M1, here he means that M1 and M2 are similar to M3. So M1 similar to M3 and M2 is a polygon similar to the polygon M3. So what we are going to deduce? We are going to deduce that M1 is similar to M2. M1 will be similar to M2. Okay? Number 2. If the scale factor of two polygons equal 1, if the scale factor of two polygons equal 1, okay, let's revise together. If the scale factor bigger than 1, then polygon M1 is an enlargement of polygon M2. And if the scale factor bigger than 0 and smaller than 1, then M1, the polygon M1 is reduction or reducing of or shrinking of polygon M2. But here, if the scale factor of two polygons equal 1, then the two polygons are excellent. The two polygons are congruent. أكيد. Number 3, if K is the scale factor of similarity of polygon M1 to polygon M2, and K, again K, bigger than 0 and smaller than 1, then polygon M1 is a reduction of polygon M2, or you can say that M1 is shrinking of polygon M2. Okay? Okay. Here, two similar polygon. Here we need to solve it. Okay, so we'll choose pen. Two similar polygon. The ratio between the lengths of two corresponding sides is 3 to 4. If the perimeter of the smaller is 15 centimeters, then the perimeter of the bigger equal kam? Let's write it together. Here, perimeter of polygon 1 over perimeter of polygon 2, perimeter of polygon 1 over perimeter of polygon 2 equal the ratio between any two corresponding sides. Here, the ratio between any two corresponding sides equal 3 over 4. Okay, so here we have that the perimeter of the smaller is 15. Which one is the smaller perimeter? Here the ratio is 3 to 4. So 3 is the smaller side. So the corresponding B1 will be is the ratio of the smaller perimeter. So we will write 15 here. Okay, so the perimeter of the second triangle or the perimeter of the second polygon will be B2 equals cross multiplication 15 multiplied by 4 over 3. This is equals to 20 centimeter. Okay, so here we will write equals is 20 centimeter. Okay, okay, let's go to another example. Example 5, in the opposite figure, if ABCD, if ABC, triangle ABC, similar to triangle AED. So we have two similar triangles. Triangle ABC, the large one, ABC, similar to triangle AED. Okay, this is a given. The two triangles are similar. So you can say that measure of angle A equals measure of angle A. Of course, measure of angle A will be equals to measure of angle A because angle A here is a common angle. Angle A is a common angle. Okay, so measure of angle A is a common angle, and measure of angle B will be equals to measure of angle E. Okay, measure of angle B will be equals to measure of angle E. And measure of angle C will equals measure of angle D. And here you know that measure of angle C equals measure of angle D equals 90 degree. Okay, so the two triangles are similar. This is a given for you. Measure of angle B equals 3x plus 10. Measure of angle B, measure of angle B equals 3x plus 10. Here measure of angle B 3x plus 10, and measure of angle A here, measure of angle A, measure of angle AED, measure of angle AED, this angle, its measure will be x plus 30. Then measure of angle A, here he wants to find measure of angle A will be equals to what? Okay, from similarity we know that measure of angle B equals measure of angle E, so we can write solution here, solution, measure of angle B will be equals to measure of angle AED, measure of angle AED. Okay, so x 3x plus 10, measure of angle B, equals measure of angle AED x plus 30. Okay, so x will go to the other side and 10 will go to the other side. Here we have 3x minus x equals 30 minus 10. Okay, 3x minus x, it will be equals to 2x. 30 minus 10 equals 20, and from here you can find that x equals 10 x equal 10. Okay, so now you know that x equals 10. So measure of angle A, here we want to find measure of angle A, but first we need to find measure of angle B. Measure of angle B is 3x plus 10, which is equals to 3 multiplied by 10 plus 10. 3 multiplied by 10, 30. 30 plus 10 equals 40. So measure of angle B equals 40. And we have measure of angle C equals 90. So measure of angle A, the last one, measure of angle A will be equals 180 minus 90 plus 40. So this is equals to 50 degree. Measure 180 minus 90 plus 40 equals 130. 180 minus 130, which is equals to 50 degree. Okay, let's go to another example. Example 6. In the opposite figure, we have ABC, triangle ABC, similar to triangle DEF. Okay? Okay? Then the length of FE. Here he wants to find the length of FE. Okay? Let's solve it together. Solution. Here in triangle ABC, we know that measure of angle A plus measure of angle B plus measure of angle C, the sum of measures of the interior angle of triangle equals 180. So we will write x plus 2x plus 3x, this is equals to 180 degree. X plus 2x, 3x, 3x plus 3x, this is equals to 6x equals 180. Divided by 6, so x will be equals to 30 degree. So x will be equals to 30 degree. Here you can write, here x equals 30 degree, b equals 2 times x, which is equals to 60 degree, and measure of angle A equals 3x, 3 times 30, it will be equals to 90 degree. So measure of angle A will be equals to 90 degree. Okay? So since ABC, since triangle ABC similar to triangle DEF, so measure of angle A will be equals to measure of angle D. Measure of angle A equals measure of angle D equals 90 degree. A will be equals to D equals 90 degrees. So measure of angle D equals 90. And measure of angle B, measure of angle B will be equals to measure of angle B, excellent, will be equals to measure of angle E equals B equals E equals 60 degree. And the last one, measure of angle C will be equals to measure of angle F, which is equals to 30 degree. Okay, but here we want to find the length of EF, so we will write the corresponding sides. So AB over DE equals BC over EF equals AC over DF. Okay, here we want to write the corresponding sides. AB unknown, DE equals 3. So AB here over 3, which is equals to BC equals 18 over FE, the side we want to find its length, and this is equals to AC, okay, over DF. Here we don't have a complete ratio. So we need to think about how to find a complete ratio. In this triangle, you can see that measure of angle C equals 30 and measure of angle A equals 90 and the length of BC equals 18. And we all know that the length of the side opposite to the angle of measure 30, the length of the side opposite to the measure of angle 30, its length equal half the length of the hypotenuse. So AB here will be equals to half the hypotenuse, which is equal to 9 centimeter. Okay? And by the same way, we know that the side length here, if measure of angle here or measure of angle F equals 30 degree, and the side opposite to the measure of angle 30 equal half the length of the hypotenuse. So since DE equals 3 centimeter, so FE will be equals to 6 centimeter. Okay, this is the solution of this problem. Or you can write here AB over 3, and we know that AB equals 9, so you can cancel AB and write 9 centimeter. And to find FE, the length of FE will be equals to 3 multiplied by 18 over 9. Okay, 18 divided 9 will be equals to 3 multiplied by 2. This is equals to 6 centimeter. Okay, thank you so much. Until we meet again next time, goodbye and good luck.